With the flight deck preparation flow and checklist complete, in addition to the departure briefing, we're going to move on to the before start flow. Start by closing all doors with the CDU like so, and confirm that all door open lights on the forward overhead panel are extinguished. We'll need to close the doors for both the passenger entry and the cargo doors. So it looks like everything's good on the overhead as well. Additionally, we need to confirm that the flight deck door access system switch is guarded and that the flight deck door is closed and locked with the auto unlock and lock fail lights extinguished. Turn on all appropriate fuel pumps. Today, these are just the main tanks, but if the center tank has more than 1,000 pounds of fuel in, its pumps must be turned on first. Next, we start the APU. To do so, we push the switch from its current position off through on and momentarily hold it in the start position. You can see that the switch just automatically sprung back to on. The startup sequence is fully automatic and begins with the APU inlet door being opened. The turbine is then spooled up and fuel automatically introduced. During startup, it is normal that the low oil pressure light illuminates, as oil pressure doesn't rise in any turbine engine until it is at a reasonable RPM. Now the APU will take several seconds to fully start up and supply us with electrical power. Additionally, we will look at what it provides with air power or pneumatic power here in a few seconds. The APU has completed its startup sequence when the APU generator off bus light on the electrical panel has illuminated. When this light comes on, start a timer on the clock for 1 minute. And after 1 minute, it is okay to use the APU as a source of pneumatic power. Doing so before this can reduce its service life, although we would not expect this to lead to anything catastrophic. Next, we will connect the APU generator to our electrical system. On the electrical metering panel, check that it is producing around 115 volts and around 400 hertz, and everything looks good there. With that confirmed, we'll start by moving the number 1 switch to the on position. This automatically disconnects ground power from the whole system. As a result of this, the source off light has appeared on the right hand side of the panel. The number 2 AC transfer bus is still powered, however, as the bus transfer switch is in auto. Therefore, the bus tie breakers, which connect both sides of the electrical system, have closed, connecting both AC transfer buses. Now turn on the number 2 switch. All of our electrical needs are now being catered by the APU. Next, we'll connect the APU to our pneumatic system, which will make us totally self-sufficient. In other words, we will be running on our own power and air. As you can see on the clock, a couple minutes have elapsed since the APU came online, so we're okay to set it as our bleed air supply. First though, we need to disconnect our ground air conditioning source, which we do through the PMDG options menu in the CDU. We can remove the external power while we're here. Leave the CDU on this page as we'll unchock the wheels in just a second. There we go. Were we connected to a pressurized ground source, we would need to disconnect that instead, as applying yet more pressure in this scenario could potentially cause rupturing. Turn on the APU bleed air switch and observe the rise in duct pressure on the duct pressure gauge. This shows the pressure in each bleed air duct, measured by sensors a little upstream of the pneumatic manifold. Pressure is measured here in PSI. When APU air is turned on, the needles will move in unison, and it will not be apparent that there are 2 needles. This is because the isolation valve is open, thus the 2 sides of the pneumatic manifold are connected. Was it to be closed, only the left needle would give a reading, as the APU duct feeds the pneumatic manifold on the left side. That bleed air can now be used for several things, including anti-icing, engine start, and air conditioning, and is used automatically for pressurization of the hydraulic reservoirs. We could turn on the air conditioning packs now, however, we will shortly be starting the engines, and so we'd be turning them off anyway at that point. The APU doesn't provide sufficient pneumatic pressure for us to be able to simultaneously run the packs and spool up the engines. However, right now you can turn on the recirculation fans to provide some circulation of air in the cabin. Now turn on the anti-collision light on the lighting panel, placing the switch in the forward on position. We won't want the strobes on until takeoff. Finally, we want to remove the chocks from the CDU, and that will ensure that they don't get in the way for takeoff. Now that we've gone through that flow, let's do the before start checklist. First, the flight deck door is locked and all other doors are closed. Fuel is indicated at 9,600 pounds. And we also need to verify that the pumps are in fact on. Passenger signs are verified on as well. MCP, we've got V2 plus 20 of 167, 080 runway heading, and initial altitude of 5,000. Now, let's go to the CDU, to the takeoff reference page, and we need to verify the takeoff speeds V1 136, VR 137, and V2 147. CDU pre-flight is complete. Now we need to check the rudder and aileron trim and make sure those are 0. Looks like rudder trim here is 0. Looking at the aileron trim, that looks good as well. Taxi and takeoff briefing are completed. Anti-collision light is on. Before start checklist complete. Now that we've done all the before start items, we're ready for movement. We're assuming all passengers are on board and the journey is ready to commence in earnest. Finally, we'll be getting some movement. It's been a long time coming. Additionally, we're also assuming at this point that we had in fact called ground control to get clearance to push and start, as we were asked to do so earlier. Because we aren't dealing with ATC today, from here on out, I'll give somewhat expected clearances that you could look out for that ATC would give you. The pushback process that we'll do next contains two very important set of procedures, the engine start and the pushback. Both have safety critical items that we must pay attention to. The complex part about this is that all of it has to be done at the same time, requiring you to be extra diligent during this phase. In all reality though, don't be too freaked out. It's a simple set of procedures just like everything else. You watch for the normal indications, perform the normal procedures, and if something gets out of line, you take the correct action. Pushback is a dangerous sequence in which we have ground personnel working very close to the aircraft. If we make a stupid move, we could be rolling a 143,000 pound machine over some guy's body today, and we don't want to be doing that. So we have a communication process with the ground crew, and we ensure that they are doing their duty down below and that we aren't moving the aircraft under our own power when they are nearby. Once they have control during the pushback, however, we are free to start the engines up and get things going from there. Besides, there's nothing we can really do to help their pushing us back at that point. Today we are going to start the engines in a number 2, number 1, or starboard, port, right, left order. The reason for this is twofold. The first is that the APU draws fuel from the left tank, and so to help equalize any fuel imbalance, the right engine gets to run for a couple minutes more than the left for the balance issues. Secondly, we do this so a late passenger could enter on the left side of the aircraft. Bring up the GSX dialog or do the P and the G pushback. We'll do the P and the G pushback in another flight. Select prepare for pushback and departure. Now we need to do tail right, nose left, and that'll set us up just right. Now we'll get a call from below when they're done hooking things up. Now is a good time to twiddle your thumbs, make sure that your seatbelt is fastened, your shoulder harnesses are fastened, and you are ready to go. This will take them several seconds. You'll hear a few bangs down below, and they will give us a call on the ground call frequency, or rather the interphone. Although very faint and you may not have heard it, the ground crew just called us and told us that they were ready for pushback. You can hear a few bangs downstairs as they're hooking things up like I said they would, and they'll come back to us and let us know when they are in fact ready.
Departure check completed. Live has been inserted. Release parking brakes.
We're asked to release the parking brake, which basically means that they are ready to go. So go down and release the parking brake now.
Commencing push. All engines clear. Start that wheel.
Note the time on the clock for movement and put it on your paperwork. I see 11:51. We've been cleared for start. We're going to do only the right engine as we want to take this process slow. We'll do the left engine after the pushback. Start by rotating the number 2 engine start switch to ground, and then move down to a better view of the throttle and the display units. Observe the start valve open alert illuminates on the engine display, and we have N1 and N2 rotation. We're looking for max motoring in this case. That is when the engine or N2 basically levels out. So once we see that, we can introduce fuel by switching the cutoff switch to idle. At 56% N2, the start switch should return itself automatically to off, which you can then hear. When this happens, observe the start valve open alert extinguishes. Monitor the N1, N2, EGT, fuel flow, and oil pressure as the engine accelerates to idle. The engine is at a stable idle when the maximum start EGT line disappears. So ensure that the number 2 engine reaches peak EGT prior to starting engine number 1. And there the EGT line just extinguished. The engine is now completely stable, and we are going to move to the other view while the ground crew finishes up the pushback. This should only take several more moments. As you can see, they are about to roll us out on the center line. Absolutely perfect with GSX. Quite the professional ground crew today, putting us right on that center line so we can start our taxi easy. As soon as they're done pushing back, the ground operator is going to ask us to set the parking brake. This makes sure that any inadvertent movement of the throttle will give us enough reaction time to idle the engines again without running someone over. So we'll wait for that now as they push us back just a little more here.
Set parking brakes.
And there we go, set the parking brake. They can now finish up their job on the ground, disconnect the tug, and vacate the area. This takes them a realistic amount of time, and then we can start to see them move away. Of course, they don't exactly just buzz off to take care of the next aircraft. They will eventually tell us that all is clear, and then the guy on the ground commences to wave us off, an age-old aviation tradition. So you can watch and observe as all that happens now. So there they are, confirming that they have, in fact, finished up their duties and they're moving away from the aircraft.
Left is clear. Right is clear.
And there's the wave off. This guy is in no big rush. He's getting paid hourly. And so he'll mosey off on the other side. And we don't necessarily have to wait for him, but we'll just watch what they do here. It's kind of realistic, kind of cool. Adds a lot of realism to the airport environment, which is important. And finally, they're off. So let's commence with the start of engine number 1 now. Back up to the start switch, you can see that the number 2 switch went back to off when we heard that click. Now we're going to put the number 1 in ground, and once we do that, we'll get to our engine start view. N2 is on the rise and we're looking for max motoring. It should only take several seconds to get there, say between 10 and 15 seconds, where we can then move the cutoff switch to the idle position, introducing fuel into the engine. Now observe as the EGT, fuel flow, oil pressure, and oil temperature all start to rise. And you can see again when the engine finally lights as the EGT peaks and falls again quickly, and then we hear that click. Now keep your hand on this cutoff switch the entire time, just in case you need to quickly shut down the engine for a fire or anything out of the ordinary. It's just a nice safety measure to have your hand right on that cutoff switch during this process. So we heard the click. Now looking for that EGT marker to disappear. And there it goes. Both engines are now started and running smoothly, so let's go through the after start flow. Now we need to verify that the start levers are in fact in the idle detent and not teetering on the edge somehow. You can imagine the danger of this lever going to cut off somehow in flight because it wasn't properly in that detent. Now up to the overhead panel for a slew of things to do. You can now see that the electrical panel, that the engine generators are illuminated, showing that we have available power. If you remember, this wouldn't be illuminated if the system hadn't been checked for sufficient power, but we'll have a look at those anyway. So first, looking at generator 1, it is running at 400 and 115, and over to generator 2, it looks like the same is true there. Go back down and turn both generator 1 and 2 to the on position, now supplying the aircraft with engine-driven generator power. Up to probe heat, both switches should now be turned on and verify that all the lights extinguish. Engine and wing anti-ice won't be used, but would be turned on now if we needed it for the airport environment or soon after takeoff. Verify both electrical hydraulic pumps are turned on, making that all hydraulic pumps on and lights dark. Let's set up the air systems now. Move top to bottom, packs, turn to auto. Isolation switch is to be in auto. Now turn the APU bleed to the off position. Just verifying here that that crossfeed valve is in auto. Now APU bleed should go to the off position. You would never want to push up throttle with both the engines and APU with supplied bleed air. If you did this, you could blow out the system, overpressurizing the system. Verify that the wheel well light is off. Engine start switches are in continuous, and the taxi light is on. All of that looks good here. And I'm also going to turn the APU off, and it puts it in its cool down period. It'll take several minutes, but all is good there. Recall, most systems are showing needed attention. Now we need to set flaps for our takeoff. We wouldn't do this in icy or snowy conditions, as ice buildup can occur in the flap components, often causing damage when trying to then retract after takeoff. So set the flaps to the flaps 5 position. Observe the flaps extend on the dial, and observe the leading edge flaps in transit light extinguish, and the leading edge flaps extended light also illuminates. So let's wait for that, and there we go. We got rid of the extension light, and now we're green. The flight controls test is all that remains now. So push the systems key on the forward panel display to display systems information on the lower DU. During this process, look out for not only correct indications, but any control spiking or jumping. If things are jumping around, you have incorrect calibrations or conflicting control assignments, which will make for a very unstable or difficult hand flying experience. So we're just checking the roll and the pitch here. You've seen both of those move. We want to observe that they do go in the right direction. That can be an issue. And then we also want to make sure that the rudder will move as well. We obviously can't do this while we're taxiing, as we're going to be using the rudder. So checking there, everything is good. In Flight Simulator, this check is particularly important as controls can often become quite messed up or easily disconnected. Doing so also gets any kinks out of your control. Now I return the DU to the condensed engine page as it's easier to see from the main view. Now we're ready to move under our own power, but we need to perform the before taxi checklist just really quick. The generators are on, prop heat is on, anti-ice is off, isolation valve is in auto, engine start switches are in continuous, the recall is check, auto brake is RTO, engine start levers are idle detent, and the flight controls were checked, and ground equipment is in fact clear. Before taxi checklist complete. At this point, we would receive our taxi clearance and proceed as instructed, but today, however, we're dealing without ATC, so I'm going to tell you that we're going to be taxiing Lima, Romeo, Juliet, then we'll cross over to runway 8 right as we talked about earlier. This taxi is very simple compared to some airports, so it shouldn't be too difficult. However, we'll still need to be diligent in maintaining correct speeds, looking for correct signage, and overall keeping sound situational awareness. There are very few things for us to do during the taxi, as we have already briefed everything we're going to do for takeoff and departure. Now we'll simply have a fresh set of eyes to look out for danger and be defensive about our taxi, always questioning our location, cross-checking, and so on. I've just released the parking brake, so nestle your feet on those pedals with your toes near the brakes but not on the brakes, and apply a sufficient amount of breakaway power. Don't jam the throttles forward. Everything you do in this aircraft should be smooth and controlled unless you are making some sort of emergency maneuver. It shouldn't take any more than 30% N1 to break away. Just as you start to roll, test the brakes. Tap one, then the other. Just a quick test, nothing that will be much noticeable in the back cabin or by the passengers. As we start moving forward, you're going to notice we break away pretty easily. For now, we want to keep the speed at about 10 knots, which will come up pretty quickly. Just like many other control inputs, we have to make sure we pull the throttles back ahead of time. The throttle response isn't exactly direct. There's a bit of a lag for the wind up and wind down time. Now, particularly in this terminal area, we need to be on the watch out for other vehicles and aircraft. Once we get on the main taxiway, it's a bit less cluttered and we'll be able to see out in front and all around. So manage your throttle smoothly with very small adjustments to make sure you stay within that 10 knot range. A very quick review on speeds with the first turn coming up. We want to be at 15 knots or less for turns of 45 degrees or less, 10 knots for 45 degrees of turn or more, and no more than 25 knots in the straightaways. Airports may have their own specific speed limits which can be reviewed in the NOTAMs. Our first turn is coming up on the Romeo, which will quickly connect us to Juliet, right in the shadow of the control tower. Keep in mind that our pivot point is not right where we're sitting, but rather between the main wheels. Although the 737 isn't as long as other airliners, we still need to compensate for the turn slightly, overshooting the turn, and then coming back to it. Seeing is truly believing here, as you can see in this turn. There isn't a tremendous amount to do in the taxi, so most of our attention is spent on making sure we are following the right taxi path and watching out for others. As we approach the runway, we'll have several things to do. Again, remember that slow and controlled is the name of the game in the taxi. The rule of thumb is to always make sure that you are in complete control, the movements are smooth, and the passengers feel comfortable and safe in the back, not like they're on a race car circuit. We're not in a huge rush to get through the taxi. In fact, if you're ever feeling rushed as a pilot, you're bound to make most of your mistakes during those times. Don't be afraid to slow down and take care of things in a more controlled manner. As a crew, things are a lot easier, but as a single pilot, this is infinitely more difficult to handle this machine, especially in a simulator. We have a critical turn coming up to the right to get us on the Juliet taxiway. Also, we're going to be close to the runway now, so we want to keep that in mind as we are taxiing around. We want to be sure that we are not taxiing onto a runway, active or inactive. This is a big turn and should be done at 10 knots or less, otherwise it'll be uncomfortable for the passengers. Look left and clear, look right and clear. There's no traffic, so we're good to go there. If we didn't turn here and rather thought it was the next right, we'd be taxiing onto a runway. The absolute worst possible thing you can do in a taxi, other than damaging the aircraft, hurting somebody, or damaging property, is taxiing onto a runway without permission. So again, this is a big wide turn to the right to get on the Juliet taxiway. So you'll see it swinging around here, pretty impressive. And we'll roll out right on center line. Now that we've turned on the Juliet, we're taxiing opposite our takeoff direction, and we have a bit of a taxi ahead of us. It is now that you can increase your speed to the max of 25 knots. Just make sure you are comfortable with controlling the aircraft, and this is doable for you. If not, practice first at a slower speed. What you want to be aiming for to achieve perfect on centerline taxi is to taxi as if the line was running along your right leg. So it won't be perfectly down the middle, rather off to the right just a little bit. We're fortunate today that we have a longer taxi, as it'll give you a bit of extra time to wrap your heads around all that is going on here and will allow for a bit more practice. It's good to think that everything is done behind us, and now, with a few more items, we'll be in the air after having determined and made the aircraft airworthy. As we approach the runway, we are going to be doing last-minute tasks. And the first is to simply press the attendant call button, letting them know that we're almost ready for takeoff so they can take their seats. Additionally, if we had any air conditioning requirements today, we'd make changes there, but there aren't any for this departure. If you wanted to use the terrain display, you can turn that on now on the EFIS. Also, we want to turn on the transponder to TARA. I've just done that. Now we can perform the before takeoff checklist. Very simple, 2 items. Flaps are 5 and green. And next, we check the stabilizer trim. And we can simply do that by moving down and looking at the trim wheel, hovering over it, and making sure it's at the correct units. Should be at 5.03. And the before takeoff checklist is complete. Now we are approaching the last straightaway here before reaching the runway crossover. At this stage, ATC would have cleared us most likely to only the holding point at Juliet 5, or they'd tell us before we got there that we'd be able to cross the runway. What we are going to do is cross the runway at the very end of Juliet, then hold short at Juliet 1 at 8 right, and talk about the takeoff procedure before we blast off. As you can see, we have just passed Juliet 6 on our right now. We have another straightaway here, which gives us the chance to talk about slowing down the aircraft properly. Now, you can obviously use brakes to slow the aircraft down. That's why the brakes are there, right? But we don't need to be powering around the airport and drifting around corners just because we can. Your taxi, as much as possible, should be controlled with power. At some point, yes, you'll need to use your brakes, but I don't want you slamming on the brakes all the time, using tons of power. Be smooth when you do this, and if possible, try and use thrust. So what exactly does that mean? That means that you should be slowing down ahead of time, thinking of what's ahead, and pulling back the throttles with enough time to adequately slow down on friction and gravity. We're coming up on Juliet 5 here, where we will then be technically in the runway environment. At this time, it is good practice to turn on your lights anytime crossing your runway to be sure you are visible to the other aircraft. So I've just turned on the landing lights, position lights, to strobe and steady, and since we're almost there and it's day, go ahead and turn off the taxi light as well. I'd imagine this will be the last time we're going to be looking at the lights. So pull ahead here and get around the corner here at the end of 8 left. When you have runways this close, parallel runways even, make sure you are on the right runway. In fact, every time you pull onto a runway, ensure the runway heading matches with the runway that you want to be departing on. You wouldn't want to be taking off on the wrong runway. You're asking for a disaster in that case. There was a notable accident several years back in Kentucky with a CRJ that tried to take off on the incorrect runway. And because they took off on the incorrect runway, they didn't have enough room to take off, or they didn't calculate for that type of performance. And crossing 8 left here, I just checked the final to make sure no one was landing. Here at Gatwick, these runways actually aren't approved for parallel landings, or simultaneous landings rather. Now come up to the hold short lines at 8 right at Juliet 1. Be sure not to stop too soon, as the visual cues can be deceiving. We want our nose right on that line, especially with little room behind us. All right, the takeoff, that is next. You'll get airborne, and then if you haven't flown this aircraft before, you'll probably be somewhat out of control. It'll be funny, just laugh it off. You can practice as many times as you like. You're not hurting anybody in the simulator. I have a challenge for you though. I want you to hand fly this thing all the way to 15,000 feet today. It's not going to be easy, and you'll most likely be completely overwhelmed at some point. But again, practice, practice, practice. The takeoff today is a quick chain of events that I simply won't have time to explain, so I want to run down with you quickly what will happen during the takeoff roll. We're going to pull out onto the runway, line up, and when ready, we will advance the throttle to 40%. So not all the way up, just 40%. At that point, we want to look for proper engine indications and any warnings. We'll know within a few seconds if all is well, and then we can advance to takeoff power. As we advance to takeoff power, we're going to enable TOGA, or takeoff go-around thrust. This will be where the beast comes alive. The system, which was set up in the N1 limit page, will follow the limits you've set. We'll keep light forward pressure on the yoke to 80 knots. After 80 knots, we only abort for major issues, as you remember in the briefing. We will quickly get to V1, our point of no return, where we will fly regardless of a failure. At rotation, we smoothly pull back on the yoke and pitch to nose up, seeking a smooth unstick from the ground. Too fast and you'll strike the tail, too slow and your ground roll will be more than needed. V2 will happen somewhere during the rotation, which is our safe engine outspeed, but we'll be pitching for V2 plus 20. Again, that will come very fast, as you will see. When we notice a positive climb on the altitude tape, I'll call gear up and we'll raise the landing gear. From there, we are looking for both the thrust reduction and acceleration height. I'll have time to point those out to you at that stage. So all this time and throughout the flight, we'll now have a major focus on the FMA, flight mode annunciators. This is where we verify the current mode and verify what is armed. No, we will not be using autopilot, but we will be using guidance from the flight director, which still depends on these modes being operated properly. That, in a nutshell, is the takeoff. Yes, it happens very fast. Yes, it is absolutely critical that if anything goes majorly wrong pre-V1, that you abort. You'll have enough runway to stop in that case, but after that, you're going in the air, buddy. Takeoff is arguably the most dangerous normal procedure in an airliner, and the 737 is obviously no exception. Careening down the runway, if anything goes wrong, the potential outcomes are few and based largely on proper training and instinct, so you must be absolutely sharp and on your game. Power up to get on the runway. You can be a bit more aggressive with the power here. We don't want to spend a long time stopped on an active runway, so we want to get there quickly. While you do that, clear the final and make sure that no one is on approach. And everything looks clear. Lights are turned on, all checklists and flows are completed until this stage. Now that we're on an active runway, you can also arm the auto throttle. As we pull ahead here, you're going to want to line up on the runway with authority and keep it rolling. You could also stop, but we may as well just keep it rolling here. Once lined up, set thrust to about 40% N1, and then you will allow the engines to spool up for several brief moments Make sure that all engine indications are green and normal. All looks good. Advanced thrust now while pressing the toga switch. This sets the takeoff thrust we set in the FMC. Keep your eyes down the runway, as aiming down there is much easier. Maintain centerline as best as possible. Around 90 knots, we go to the throttle hold on the FMA. Accelerating toward V1, your movements should be smooth and commanding to maintain centerline and good control authority. There's V1. Rotate, pull back smoothly on the yoke. Don't jam it back, just nice and slow to ease it off. It happens quick. Pitch for the speed we said earlier, V2 plus 20 as seen by the magenta marker. When you see positive rate on the VSI, pull the landing gear up. You'll notice now as we pass through the different FMA indications, the LNAV and VNAV start to arm. At about 400 feet, VNAV will finally go from arm to active. Now we see N1, LNAV, and VNAV all active. Your job now as you hand fly the aircraft is to hold the indications on the flight director and do so with precision. We've just passed the thrust reduction at 1800 feet, and so the engines are throttling back. Now we're looking for 3,000 feet, and that's going to come up awfully fast for us here. As we reach 3,000 feet, the speed bug will disappear and it will jump ahead to a higher speed. This is where we accelerate, or our acceleration height. So you can see it just did that now. Now the aircraft is nosed over, even with the indications on the flight director, and we accelerate through the flap settings and clean up the aircraft. As you pass through the green flap setting number, you can set that number of flaps, or you can simply wait until you're past the up indication and pull the flaps all the way up. It doesn't take too long to get there, but keep in mind we're exchanging climb rate for acceleration now, so we're leveled out slightly. The flaps continue to retract as they take a bit of time, and you can see that the speed bug is also jumping up as we get to a safer operation as the aircraft continues to accelerate here. The speed will not go above 250 knots below 10,000, which is the restriction we've set. All right, in all that chaos, we've come right up to about 5,000 feet here, so we're going to level off. This is our initial altitude we were cleared to, and the restriction on the climb profile per the instrument departure. Remember to continually use trim as you change the aircraft's profile. You will have changed trim right after takeoff, thrust reduction height, acceleration height, and now that we're leveling off at 5,000. Anytime you're significantly changing the aircraft's pitch, speed, climb, etc., you're going to need to retrim. Trim is your best friend for maintaining smooth, hand-flown flight, which we are doing a lot of today. Things have settled down slightly for the moment, so let's discuss briefly about hand flying technique. As was mentioned in the obstacle course video, you need to be smooth with everything you do. But now we are dealing very much with not only flying smoothly, but doing so while keeping the indications on the flight director. The flight director is our guide based on the modes we have set in the MCP and how these modes interact with the information in the FMC. It will take a bit of time for you to get used to flying the flight director. What you want to do is keep the black dot in the middle completely obscured by the vertical and horizontal lines. The vertical line represents the lateral path we are to follow, so we roll toward the line and we'll capture that line based on our bank angle. Use this in harmony with the ND indications of your path to anticipate the movements of the flight director. You can see now that we have a turn at over 31 DME, so we'll be able to practice anticipating there. The horizontal line on the flight director is our vertical profile and is captured much the same as the vertical line. Now we can perform some important after takeoff functions. First, turn the auto brakes from RTO to off. This disables that system. Now pull the landing gear handle from up to the middle off position. This removes any hydraulic power from that system. After that, let's perform the takeoff checklist. Engine bleeds are still on. Packs still auto. We didn't mess with any of those. Landing gear is up and off. Flaps up and no lights. After takeoff checklist complete. At this stage, we are on the Clacton 5 Papa departure, held down by a fairly significant and rare altitude restriction. It is very likely that ATC has these as a basis for all the traffic going into London, and while traffic permits, aircraft will have been cleared to a higher altitude than is depicted on the chart. Keep in mind that the chart is not the way it is absolutely always supposed to be. It's very common for ATC to turn you to a different course and approach based on vectors. In our case today, it'd be nice for us to in fact assume that this is the case, as it's a bit pointless for us to be flying at 5,000 feet for long periods of time. We need to get up to where the air is rare. Because it is the FMC restricting this altitude per our entered flight plan, and the VNAV holding that vertical profile as a result, it's through the FMC that we must change this. Technically, we could fit in a flight level change and start the climb, but we're not going to do that here. Set your MCP altitude to our cruise altitude of 23,000 first. And this ensures that when we do change it in the CDU, that everything will shoot right across. Go to the legs page of the CDU. From the legs page, we can see the altitude restrictions on the right-hand side. Any large type is procedure calculated information that can be modified. Small type is the automatically generated altitude calculated for that leg and is subject to constant adjustment. We need to delete the altitude restrictions here noted by the large type. So hit the delete keys and delete each one of those in the right-hand side. There are 2 of them. And then after you've done that, you can hit the execute key. And because we've already set the MCP to that higher altitude, you can see that now the VNAV has started that climb for us. So we set the altitude in the MCP, we deleted the restrictions from the CDU, and now the VNAV knows to continue our climb. Now the aircraft should obviously follow this vertical profile in the VNAV, as those restrictions had been deleted. Now press standard on the EFIS, and that'll set our standard altimeter as we have just passed through the transition level of 6,000 feet, which we had set earlier. As was mentioned earlier, you can now use the ND along with your flight director indications to wrap around this corner. On the ND, you can wrap the turn vector to perfectly match the curvature of the turn itself, as you can see here. Continuing this trend, simply bend it like Beckham around this turn and keep it coming around. This is a significant turn, so you'll be in it for some time, but it'll give you a feel for the coordination in a good bank, especially at this altitude. Now, as we come up here, passing through 9,000 feet, we are going to be coming up on 10,000, which sets in motion several new things for us. First and foremost, up front here on the flight deck, we are now past our speed restriction, and we are clear to accelerate to a cruise climb airspeed. You'll notice that the VNAV automatically does this for us per our settings. As you can see, if it is set up right, the VNAV is a very intelligent system which through the flight director and AFDS can assist you greatly. We'll now run through the 10,000 foot climb flow. It's fairly simple, so follow along. First, we want to get up to the overhead, and there we will press the attendant button. This tells the flight attendants we passed through 10,000 and they can start attending to their duties. Beverage service, if there is any, will be very short today, as our cruise will last only several minutes, but they can attend to their other duties regardless. Next, check the cabin pressure is within normal limits. You can see that the small hand is pointing to the cabin altitude and the large hand is pointing to the actual pressure altitude. Cabin altitude is quite low here and looks good. We can also see the cabin climb rate is quite normal, just a few hundred feet, which is within a comfortable range. Cabin temperature can also be adjusted if needed. The flight attendants may let us know if things get a little too warm, and this actually isn't simulated, but nothing wrong with pretending, right? Engine start switches should be set as needed. In our case, out of the clouds, these can be set to off. APU, if it were still on, would now be turned off as its operating ceiling is coming up pretty quick. The auto brake panel again would be set correctly. This isn't part of the after takeoff checklist or flows, but I usually take care of it when I do the flaps and gear after takeoff, so that's already set correctly. The gear handle again is off. And the fuel system for us in this flight is pretty simple, just fine. We don't have anything in the center tank, so we're working with wing fuel only. No changes in our case today, as we can see there. And that does it for that flow. Pretty simple, not much to it. Now that we're back in the main view here, you may have gotten a little wobbly in your hand flying duties while you were heads up and heads down taking care of the climb flow. Truth is, it's probably best to use hand flying just through 10,000 feet, as the autopilot can fly much smoother at the higher altitudes than you can. That's just the truth. Also, in a single pilot environment, it gives you the chance to get a little extra help for times of high workload. With that said, and because we've had enough of the hand flying, it's time to engage the autopilot. Just above the ADI, you'll see the letters FD for Flight Director. Right now, we're still on Flight Director guidance, obviously, as we haven't made any changes. We've paid very close attention to the flight mode enunciators, but this area is also important and is included in the flight mode enunciators. However, if you go to the MCP and select Command for the left side, you'll see it will go green and active. Release your hand from the yoke and watch now as Auto takes over the flying duties for you and magically guides your path via the selected MCP modes to the left of that command switch. In our case, again, those modes just so happen to be controlled by the FMC through VNAV and LNAV. Later, you'll see other modes in use. Now above the ADI, you can see that it is CMD for command. And this highlights for a few seconds, which has already passed now, but then it goes to this normal indication. At this point, we should have already done the 18,000 foot climb flow, but we are very short on time and we'll do that after we do this next step. What I want you to do is get to the CDU and select the progress function key. At the top we see AOA 73 Alpha progress and then subsequent indications for where we came from, where we're going next, the waypoint following, our destination, and the top of climb. Other than the first waypoint, which was our last and shows actual altitude and actual time crossing and actual fuel remaining at that point, we have distance to go, ETA, and fuel remaining for the remaining points, or the points in front of us. In our case, we are particularly interested that the FMC matches our paperwork, and those numbers are all correct for Rotterdam. As of now, the FMC is saying we'll have 4,700 pounds of fuel remaining, while the paperwork shows 5,400 pounds, so a little bit of a discrepancy there, but not too much to be concerned with. You can just hear the 1,000 foot warning on the climb there now, so that means that we want to get back to the main view here, and we're going to run through the flow that we should have done at 18,000 feet. In the US, 18,000 feet is the transition level. We've already done the transition level, so in our case, the only remaining thing we need to do is turn off all of the lights that we had on. So we turn off the landing, runway turn off, and check any other lights that could be turned off, including the logo light. Anyway, that's a simple and quick flow here at 18,000, or what would have been 18,000. Now we can get into the arrival planning, or the descent planning. That will take some work. However, we're going to get through the turn up here at Daga, and then we will get through that. If you need to check anything in the progress page at this point, you can do so, but I'm going to show you here in a few seconds how to tell exactly how much time you have until your top of descent. And believe it or not, we're going to be at our top of descent in less than 10 minutes. This is your time to prepare any paperwork that you need, gather everything together. It's probably best for a flight like this, where you already know that it's going to be pretty short, that you have everything prepared already. However, this is your last chance. If you need to pause the video, do so. However, we will get into the turn here at Daga, and then we will get to our arrival planning. Now that we're at the cruise altitude and we're about to go into our descent planning, we need to do a few things ahead of time, out of schedule, before we actually get into our descent planning. The reason being is that we are going to pass our top of descent while we have this next discussion. That's how short our cruise phase is here. So it's only several minutes. It's even shorter than we show here. All right, so right now, let's look at the, just to show you how short it is, let's look at the progress page. I'm showing the top of descent at 12:37, so keep that in mind, okay? 12:37, that's when top of descent is. The first thing we're going to do is we are going to set the MCP altitude to a lower altitude so that when we do run over in this discussion, the aircraft will start descending on its own. Now, this isn't something you would do without proper clearance if under the control of ATC. You wouldn't set a lower altitude and just decide on your own that you're going to descend. Remember that in IFR, you are completely controlled by air traffic control. They ask you comply with few exceptions to that rule. In this case, let's set the MCP altitude to 10,000 feet, and that should get us started pretty well, and then we can bump down a little bit more from there on our own discretion. The aircraft will not descend from our current altitude again unless we make this change. If you forget to change the MCP altitude, you'll get a polite reminder from the FMC through the CDU that you need to reset the MCP altitude. All right, so before we get into the rest of our descent planning, let's look at the CDU. We're going to enter our departure, or rather our arrival, into Rotterdam. So hit the departure arrival function key, hit arrivals for Rotterdam 2 right, and then we're going to be doing the VOR DME runway 6 approach in 3 right. Select that first, then the transition. We're going to be doing Mesos transition, and from there select the Redfa 2 on the next page, the Redfa 2 Romeo arrival, and hit execute. Going up to this view now, or rather let's look at the progress page. So we're 1 minute sooner, and that can make a big difference when we start our descent. So our top of descent is 1 minute sooner. You can see it here on the ND, and that's where we will start on down. Now I do see here that there's probably a discontinuity at Redfa. You can see kind of that double line there. This often happens when you enter in an arrival or a departure. So let's jump into the legs page quick and just clear that out. So I'm just going to select Redfa into the scratch pad here and then drop it on top of the other Redfa, hit execute, and that clears that discontinuity. All right, so we've done that. We're going to be descending here in just a few minutes, and now we can start to have a discussion, which I will interrupt, on the descent, the charts, setting up the aircraft, etc. We would now go through what is called the WCAP arrival checklist. This is a memory item and not something you'll see in our flows or checklists, but much like the departure briefing, this will get you fully familiarized with the arrival, approach, landing, and information on the airport grounds themselves. First, we go to the weather. Ahead of time, we need to get weather for Rotterdam. This is done by doing a search on the internet if you're using live weather or looking straight from your weather program. In our case, Active Sky. For me right now, let me bring up Active Sky. Currently, Active Sky, or rather Rotterdam, is reporting winds 03010 knots. The winds are variable between 340 and 060. Visibility is clear, no clouds. We've got a temperature of 7 dew point 2, QNH 1007, and no significant other weather. But in the TAF, we do show that there is some clouds and a possibility of rain, and that's why we're going to be using anti-ice here in a little bit. So we're coming up on the top of descent here. We'll continue with our conversation here. But based on the winds, and as expected, we'll be using runway 6 in Rotterdam, and we already selected the approach for runway 6. Additionally, we'll be doing, again, the VOR runway 6 approach. Non-precision approaches are a bit more difficult, but we'll see how you handle getting the kitchen sink thrown at you in this, your inaugural flight. As we discussed before, the weather coming down is also something we need to watch out for with those, with what we saw in the TAF. So again, let's plan on using anti-ice once we get close to visible moisture, and we'll plan on turning it on, or rather off, after we land. We won't expect too difficult of an approach because of the higher ceilings, but we will be on our toes. In other words, we're not going to be limited by weather too much today. Next, you would do the CDU setup. We've already done the actual approach part of this, and as you can see, we actually just barely started descending, so you can see why we actually set all that up. But now I want to get in and show you a cool little trick that will help you guys out a lot. So get into the fix page and enter in Rotterdam, so the airport that you're going to be using, Echo Hotel Romeo Delta, and then we're going to be doing /10 in 2 left and /20. Oh, not 200. 20 in 3 left. Look now on the ND, and if we zoom out a little bit, you can see now that we have 2 range rings here for the airport. You can see that inner ring of 10 nautical miles, the outer ring of 20 nautical miles. The 10 nautical mile out means that we basically want to be in the landing configuration by that point at our reference speed. In other words, we're fully prepared for the landing. 20 nautical miles out, we want to be at a max of 250 knots and 10,000 feet. This isn't always possible, but if you're doing a straight-in approach like we are today, it'll be quite difficult to get down in time and on speed without some creativity and intervention. We want to make things as smooth as possible, and these 2 rules of thumb marked on our map will allow us to have a visual reference. At this point, we would go through and we would set up the actual approach in the CDU, but we've already done that, so we don't need to do that again, obviously. One thing you could do here ahead of time in the CDU is you could set your approach reference. So click the initialization reference function key, and at this stage in the descent, this is going to show automatically. We're going to do a flaps 30 approach today. So go ahead and just copy that in by pressing line select key 2 right and drop it in flap speed 4 right. And so that sets our VREF now, and we could do that later on, but while we're there talking about the CDU, we may as well do it. All right, now for the airport information. What we want to look out for here is for general information and familiarization. We have frequencies at the top of the chart, in addition to airport elevation, coordinates, and so on, just the general stuff you would usually see. Then we get into the plan view of the chart, which shows a top-down of everything in the area. You even get a bunch of little markers that show obstacles. We will be approaching from the southwest today, landing on runway 6. The runway course is 057, although the approach course I can tell you will be 058. Runway length is 7,217 feet long, and it's 147 feet wide. Also noted is the type of landing light system on each end. Then in gray, we can see the layout of the taxiways. This airport is so small, there's not a separate taxi chart. We'll plan on vacating the runway at Victor 2, if not Victor 1. We'll taxi back on Victor to the apron, and I think we'll use a follow me car here too. The apron doesn't have any gates, so we'll be using air stairs in our designated parking spot in Rotterdam. Textual information is also available for the runways, including the takeoff minima below. We can also have a look at the landing minimums on the next chart, but we'll be covering this more fully and comprehensively. So let's go to the approach chart now, but actually before we do that, I want to note here a couple things. We passed through 18,000 feet. We didn't have our transition level set correctly, which is why standard is showing here on the PFD. So I'm not completely sure if we can change that now, but if we go to the forecast page, I clicked on the descent page, function page, and then forecast, we can change the transition level. It's going to be 030 today, 3,000 feet. We can put that in there, and then if we go back up, we can see that now the standard notification is still green, which means that we're good to go. Also, we are in visible moisture now, so I'm going to turn on our engine anti-ice and wing anti-ice, and then that is noted on the engine display with the anti-ice above the engine. We've also passed through 18,000 feet, which means that we can complete the 18,000 foot descent flow. Basically, this is a PAX flow and a lights flow. So if we go to the lights, we can turn on our runway turn-off lights, our landing lights, not the taxi light yet, APU no. We can turn our engine start switches to continuous, and we will turn our wing lights on as well, since we are in icing conditions. At this stage, we would set our altimeters if we had passed through that transition level. All right, so we're coming in even closer now. We're coming up on Mesos. We're currently at 13,400 feet and coming down quite quickly, so we need to go over the chart here before we actually arrive. This is better to have done earlier. All right, so now to the chart. Here we have the VOR runway 6 in the Rotterdam. We need to pay particular attention to the kind of approach this is, as it will dictate how we fly the approach. What I mean by that is that this is a VOR approach, and therefore the VOR must be used as the primary form of navigation during the approach segment, and not the IRS GPS we're using now, or the LNAV like we're using now. Now we are going to go through the facts of this chart. So this is an acronym, starting with frequencies. At the top we have our communication frequencies in the information area of the chart. This is very helpful. These can be pre-tuned if you desire in one of the comms, perhaps the one you're not currently using. Below that, we see frequency for the VOR of 110.4 and more information next to it, including the final approach track and other altitudes. We'll get to those in a few seconds when we install all that information together. Next in facts is altitudes. What we want to look out for here is not only the airport elevation, but also what our altitude changes are throughout the approach. In this case, we stay at about 2,000 feet and cross the final approach fix at 1,870 feet precisely. Then we are allowed to step through our altitudes on the approach per the approach DME fixes. In our case, we are going to set a vertical descent, and it should take us on a nice glide path to the runway. Our minimums for this approach, or our MDA in the case of a non-precision approach, will be 580. So you just heard a chime. That was the MCP, or rather the autopilot system telling us that we were approaching our MCP altitude. I'm going to set this now for that initial approach fix, or rather final approach fix altitude that we just discussed of 2,000 feet. All right, now for the C in facts, which is course. We will be connecting on the Mesos initial approach fix, which is coming up ahead, and that'll link us up to the final approach path. It should be a fairly easy approach from there. Once we intercept the VOR signal and start to track it, we should be on a final approach track of 058. So you can tell here that we have a lot of numbers to memorize and enter in. Terrain, because we're basically in a low flying area, or rather a low lying area, not a low flying area, The terrain isn't a big deal today, but reviewing the obstacles in this area of the chart, and especially the minimum safe altitude for the surrounding area, is helpful. Now for the safety and summary. We will be doing a simple VOR approach today. VOR navigation will be our main source of course tracking. We'll use the ND display on the right hand side for any additional situational awareness we need. The frequency is 110.4 for the VOR. Course is 058. We'll be at 2,000 feet until we hit the final approach fix at 8.4 DME, where we'll start down at about 750 feet per minute to our MDA of 580 feet. No real terrain issues in the area. In the event of a missed approach, we'll climb straight ahead on 058, or rather a 058 heading to 2,000 feet and inform ATC. Now we need to install this information. You can see that the, just real quick here, kind of distracting you guys, you can see here that the autopilot, or rather the VNAV, has automatically pulled our speed back at 10,000 feet. So now we're at a much lower airspeed, and we're coming on into Mesos and continuing our descent now. So we're looking good on speed and on track, and we'll be very diligent in making sure that we're getting down on time. All right, so we need to install all the information like I said. First, we need to install the frequency of 110.4. Just go ahead and do that on the COM, or rather nav radio, and then make it active. Now going back, we can verify on the ND. Here, I will turn the VOR on. It does identify it is Rotterdam, 40 nautical miles away, and the pointer is pointing toward that station. So we have just verified the VOR. We don't have to listen to the Morse code or anything. Let's set the course on the MCP to 058. Now we need to set the MDA on the EFIS panel. This takes several seconds. It's a barometric MDA. You can see it on the PFD as I dial it in here. And we're gonna set it for 580. Takes a couple seconds to get it, but you can get a very, very precise number. And at this point, we'll get some RL alerts that we are at minimums. So barometric 580 minimum. We've got a reference speed 2 shown here. So all that's looking good. And at this point, we could set our transition altitude as well, but because we were descending through all that stuff, we had to do it early. All right, so we did pass through 10,000 feet during this process. I didn't necessarily want to interrupt you guys again. Simply at this point, we want to tell the flight attendants that we are descending. We've passed 10,000 feet. They don't have an altimeter right there with them, so we can just notify them with the attend button. We check the pressurization panel. The cabin climb is actually not climbing, it's descending. Our cabin altitude looks good, and our actual altitude looks good as well, or our pressure altitude. Checking all the lights again, checking our landing altitude, that's all verified. And now we can do the descent checklist. Pressurization, we just checked our landing altitude, we checked our pressurization panel. We can go and recall any issues we have, no issues. Auto brake, we're going to set auto brake for 3. Landing data, let's get to that page in the FMC. We've got, you just saw that drag required. I'll talk about that in a couple seconds here, and we need to get on top of that quick. We've got flaps 30, speed 146, and the approach briefing is completed. So drag required means that it doesn't think we're going to make our descent pass. So I'm going to pull in our speed brakes, and you can see that here in the flight detent, the full flight detent. I have this programmed on my yoke, or rather my throttle, with a lever, so I can do that without looking. And now we can get down even sooner. Now let me talk about this green range ring here. This green ring is the point at which we will capture our set MCP altitude. So because we are set for 2,000 feet on this particular approach, we are going to reach that in time. We're going to get down here and we'll be okay. The only issue is that we also have to slow down during this process, which will make that a little more difficult. But at that point, we should be right around 2,000 feet, which will help quite a bit. And so we'll watch that. I'll show you guys some techniques if you're coming in hot and fast, kind of like we are now. So at this point, if you don't already have it, it'd be a good idea to make sure that your approach chart is readily accessible and that you are in fact ready to execute this approach. This is a good time to review the information, as in several moments here we are going to be far too busy to handle anything else. All right, I'm out of visible moisture now. I said that we would turn off anti-ice on the ground, but we can actually do it now. So let's go ahead and turn off our anti-ice. And all looks good there. And here in a couple seconds, the VNav will command a decel. You can see that on the ND, it says decel. You'll see the PFD switch as well, so you just saw that it switched there. I'm going to do our first notch of flaps. And then I'm going to do a speed intervene and keep our speed up so the MCP will continue descending for us, or rather the autopilot will continue descending for us. So basically we're still in VNav, but speed intervene lets me dictate how fast we are descending. We're still in our operating range for our flaps here. I just want to make sure that we get down in time to be able to level off. Again, I still have speed brakes in, and one of the rules of thumb with speed brakes is you do not let your hand off of the speed brakes until you're ready to take them out. Because I'm a single crew today and I'm not an octopus, I don't have hands that I can be putting everywhere. So that's just important to recognize, that you do in fact need to be aware your speed brakes are still in. But if we come down here to 3,000 feet, or rather 2,000 feet, and level off, we can quickly get slowed down. I'm going to change the range on my ND now to more of a just a better range for what we're working with here. Also at this point, we need to arm the VOR localizer mode, because we are going to track the VOR approach. Like I said earlier, we cannot track LNAV here because this is a VOR approach. We have to track the actual VOR. So coming down here, I'm going to dial the speed down even more. It's not going to help our case, but all right, and 10 nautical miles out, you can see that range ring coming up. We want to be at our landing configuration. I'm going to put the landing gear down. That gives us a lot of aerodynamic drag. And I'm going to start bringing in more flaps. There's flaps 5. And we're coming in just a little bit high. Need to go to VOR mode. And you'll watch for that on the PFD to go to active, and there it is. You can see we also just switched from standard, so I'll switch that and set our altimeter. I'm still on autopilot at this point. Things are very busy. You could hand fly this entire thing, and I'm actually going to take it off autopilot now. And here we go. And I'm in full command. Silence that warning. And here we go. So we're descending on the approach now. I'm still not in my full landing configuration. I'm going to get to final landing flaps. and come down the reference speed of 147 and take out my speed brakes. All right, so we're looking for 8.4 DME before we can start down. Right now we can stay at 2,000 feet or above. And actually went one flap setting too far, so I'll bring that back out. But we want to maintain our minimum altitude here again until 8.4 DME. And then we can start down. And the VOR is a little more tricky. It's not like following your LNAV. But we can still use the flight director guidance to help us out. And we're past that 8.4 DME, so I can start on down. I'm going to get command of my thrust too. And now we're basically visual with the runway. We could go full visual, but you can focus on your on the indications as well, just to get a feel for what it's like to fly this approach. And we can do a final panic check at this point. The gear is down, 3 green. The flaps are set. We have a little more to go on our speed, and we are all set up for the approach. Auto brakes are 3. And we want to arm our speed brakes. There we go. Everything is looking good so far. Now the landing technique is very interesting on this aircraft. You basically do not flare until about 30 feet. And it's a bit disconcerting. You'll see that here. It's a couple second transition. You go from being in full descent to landing in just a couple seconds. You can see our minimum coming up on the altitude tape. Once we hit that, it'll say minimums.
Approaching minimums.
Now that we have the runway in sight, we are landing. This is a declaration made by the pilot flying. As we come on down here, we want to make sure that we stay on path. The natural reaction is to pull up as the ground gets closer. This is quite a different visual sensation as we now have objects that are moving fast past us. Again, we want to get to about 30 feet before we flare, and until then, we want to keep our descent coming on down. Everything is visual at this point, absolutely everything. You are not looking inside the cockpit. And we are going to come on down here.
50, 40,
30, we can start the flare.
20.
And we want to set the wheels down firmly. There we go. Wheels are down. Now bringing in reverse thrust. I see that the auto brakes have disarmed. That means that manual braking is going to be up to us. And we need to make sure to get on that. These speed brakes are deployed as well. And then as we slow down here, we want to make sure to take reverse thrust out at 60 knots. Otherwise, we may pick up rocks or other debris on the runway that can come through the engines. So there you go. A successful landing, a successful approach, and you can just see how incredibly busy it is. It's even more difficult on these shorter routes. You would think that with a longer route would come more complexity and you wouldn't be able to get everything done. Or rather, it would just add a lot because of the long route and all the extra paperwork, the fuel figures, things of that nature. But that isn't so much the case. What we want to do is we want to pull past the hold short lines here. Just make sure that we're not in the air, or rather the runway environment, or rather our butt isn't in the runway environment. And so we'll stop right about here. And we will go through our landing flows now. We want to put our flaps up. Basically, everything we set up for approach can be taken out. So we can command our flaps all the way up, and that'll give those time to retract. We can also take our speed brake out. So I didn't land that way. That was forced full up when the ground sensing unit determined that we had landed. And so it assisted in shifting the weight from the wing to the wheels. Transponder, we can move on down there and go to standby on the transponder. And the auto brake, we can turn to the off position. Now I'm guessing why the auto brake disarmed is because we still had a little bit of thrust. For some reason there was a little bit of a blip in my throttle that caused the auto brake to disarm. If you have any thrust commanded at all, it'll disengage the auto brake. That can be convenient once you're done with the auto brake because you can just bump the thrust up a little bit. But in our case, it disarmed them for us and we had to do manual braking. All right, so now what we want to do is we want to request the follow me vehicle. It'll take him a couple seconds to get down here, a couple minutes rather, and that'll give us time to go through more of the after landing flow. We've only done the first few items here. So let me do that now. Let's say we're going to go to gate B and gate B2, and let's see how that works. Request follow me, yes. And so they will be coming on down, and then we will follow them. Even though this is a simple airport, this is just a really cool way with GSX to get some guidance on the airport environment. All right, so what we need to do now is we need to turn all of our lights off. We can basically go down along this panel and make sure that everything is taken care of. Landing lights will come off. Obviously the runway turn off lights. We can turn the taxi light on. At this point, we could turn the APU on, but we're just going to connect up to ground power before we shut down the engines. So you can leave that off. I'll show you how to do that in a different flight. Turn the engine ignition switches to off. Logo light you can turn on. Anti-collision light off. Wing light off. And we'll turn the wheel well light on when ground services are handling those kind of things. All right, so the engine and wing anti-ice, again, we turned that off prior to our arrival because the visibility got so good. The pitot heat switches can come off at this point, or rather the probe heat, and so can the window heat. You can also do this later. It depends on what you're planning on doing, what the weather's like, but because things are so clear today, and we're not really concerned about the windows fogging up, we can just turn all that stuff off. We're not really concerned about it. And that really does it for the after landing flow. If we were to start at the APU, we could monitor that a little more. And then during our taxi, we could switch to the APU power and air and things of that nature. But for the most part, we're set up good the way we are. So there's the follow vehicle. He's all ready to go. And so we will follow him. We're a lot lighter now. So go ahead and power up. And as you do that, note your landing time here. So 13:05, and we've been talking for a couple minutes here. So you could say 13:02 was our landing time. And just very simply, we want to follow this guy down. I think he's going to go about, we want to keep things at about around 20 knots. This can be tricky because these guys kind of do whatever they want. So we're going to watch him very closely and make sure he doesn't do any funny business. See, we're already going too fast here. Man, he needs to speed up. He needs to look in his rear view mirror, huh? So I'll keep things right around about 25% N1. We'll see what kind of speed that gives us. We're still going a little faster than he is. But wasn't that crazy? We had a lot to do all the way from takeoff, all the way to landing. And now is really the first silent moment that you guys have had. The VOR approach also went by very fast. More or less, it ended up being a visual approach assisted by the VOR. But regardless, I felt like it was successful. I felt like we watched our speed and we got down in time and did a very good job with utilizing what we had to get down in time. You know, there are improvements that we can make to every single flight, and it's not always going to be perfect. I have a list of things that I know that I could have done better on this flight, and one thing I want to start doing is I want to start doing a departure briefing after these flights. So that means that after this flight, you can expect to also view the departure briefing for this, the first FLIGHTWORK flight. And we will go over the problems, what I saw could have been done better, the mistakes that I made, and therefore you guys can learn from those. If you didn't notice any mistakes that I had made or any anomalies in the video training, then I challenge you guys to go back when you redo this flight, because I'd imagine you're going to have to redo it, and look for the things that are off, look for the things that aren't quite set up right, and let me know what you see. It'll be a good test of your knowledge. All right, so he's telling us that he's going to be turning left here. And so will we. Looks like Bravo is on this second row here. So he'll be turning right up here. Anyway, we're going to be doing a departure briefing, and I hope you guys enjoy that part of it too. Here we are. They're guiding us in. We want to go a little slower at this stage. I think this guy on the left here is getting a little too eager with the air stairs. I think we'd probably clip that if this is the real world. And we have the marshaller telling us that we need to go a little left. Okay. And here we go. He's closing up. A little more power. Just creeping on in. And there we go. Alright. So let's go and set our parking brake. We're going to go to the CDU quick and set our ground connections. The ground power and the air conditioning unit. I'm going to go over to the overhead panel and check the ground power frequency. Everything looks good there. Turn on the ground power. And so now when we go to turn off the engines, then we aren't going to disconnect all our power. So let's go cut off now. And as quickly as possible after we've done our necessary steps, we want to turn the fasten seatbelt sign off. And that way everyone can get up and start to unpack their bags. As you know, passengers are generally very eager to get off the airplane, and especially today with all of the training that we were doing on the ground. They have been on the aircraft far longer than they had planned because of the pilots on board getting a little too wordy.